Okay, so this is the first video that looks at the Year 7 topic, solids, liquids and gases and particles. So we're starting first of all with solids, liquids and gases. And before we can go any further with that, we've got to consider the question of what is matter, because everything that we're talking about now, from now on, concerns matter. Matter is just that word that scientists give to anything that takes up, that has a mass, and takes up space. So stuff, right? Any and all stuff in the universe is matter. And we call solids, liquids and gases, we call those the three states of matter. So matter can exist as a solid, it can exist as a liquid, and it can exist as a gas. Now, one of the things that distinguishes solids, liquids and gases are their properties. So one thing for you to think about before we carry on much further with the video is which state or states, so which of solids, liquids and gases can flow. So have a think about that. Which state or states can change shape. Again, have a think about that. And then which state can change its volume. So maybe pause the video, have a think about those questions. Make some decisions, make some answers, ideally write them down if you can, and then press play to continue. So if we consider solids and we think about how we can define a solid, one thing about them that's always the case is that they have a fixed shape and a fixed volume, and what they do not do, absolutely do not do, is flow. Because they have a fixed shape and a fixed volume, that means they always take up the same amount of space. We can typically cut them, and some of them, metals, can be shaped. So these are things particular to characteristics. So if you think about a metal, you could maybe draw it out into a wire, and once you had done that, it would stay in that shape. If we think of some examples of solids, then we've got some down here. We've got ice, a brick, gold bar, wood, sand, salt, and then some non-examples on the right hand side and right bottom corner. We've got water, steam, olive oil, honey, milk and air. If we think about liquids, the first thing that distinguishes them from solids is the fact that they can flow, but like solids, their volume stays the same. We're going to be able to explain these properties when we get to the particle model of matter in a future video. Thinking about their characteristics, well, they can change their shape, and in fact they take up the shape of whatever container they are in, but they still always take up the same amount of space or the same volume. Again, thinking of some examples, got water, sunflower oil, milk, mercury, and then some non-examples, ice, steam, oxygen, carbon dioxide and helium. You may not be familiar with all of those examples and non-examples, but hopefully you're familiar with enough of them to get an idea. Finally, gas is the third state of matter. So they do not have a fixed shape, and they will spread out and change their shape and their volume to fill whatever container they're in. So that is completely different from both a solid and a liquid. They are typically invisible, although not always. And something that is very different to solids and liquids is that they can be squashed. Again, when we consider the particle model later, that's going to explain why this is the case with gases, but isn't the case with solids and liquids. And then we've got our examples in the bottom left there: steam, oxygen, nitrogen, carbon dioxide, helium. And then some non-examples, some of which were examples in the other states of matter. Now, you should have done solids, liquids and gases, I think, in year 4. So hopefully quite a lot of this is a reminder of what you did then, although maybe you didn't use the exact same language that we've used here. We are going to revisit this. We're going to come back to this because when we do the particle model, we're going to think about how the particle model explains some of these characteristics, and so we will repeat those characteristics. Something else that you should have done in year 4 is the idea that we can change state. So we can go from a solid to a liquid, or we can go from a liquid to a gas, or vice versa. So it's important to recognize that most substances, I mean, the vast majority can exist in all three states of matter. It doesn't mean they do naturally, but the possibility of them existing in any of those three states is important. And the thing that affects which state a substance is in is the temperature. So whether something is a solid, whether something is a liquid, whether something is a gas, is going to depend on the temperature of that substance. And therefore, if we think about that, if we change the temperature, then we have the possibility of changing state. And that's probably something you're familiar with if you think about how a kettle works, and if you think about how you're putting in water straight from your tap. It might be cool, that water. You switch the kettle on and you know that the water is boiled, ready to make the tea or the coffee or the hot chocolate or whatever, when you've got the steam coming out. So we've got going from a liquid to a gas, where we've got the steam coming out of the sort of the kettle spout. So to repeat, whether something is a solid or a liquid or a gas is going to depend on its temperature. And what that means is things that you may only feel exist as gases, for example, oxygen, can, if we change the temperature enough, and in the case of oxygen, make it low enough, we can actually make it become a solid. And it's unfortunately you can't use the link on the screen here, but that link there where it says solid oxygen is a video on YouTube which shows them cooling down oxygen so far that it becomes a solid. So that is something you could search for if you wished to see that that's the case. Equally, things that you always think of as being solids, say metals, for example, they can change to become liquids, or they can change to become gases, providing that they don't actually catch fire or break down before that happens. So this is gallium is a lovely example. So it is a metal at room temperature, but actually its melting point is only, I think, maybe 10 or 15 degrees warmer or hotter than room temperature. So it is possible to make a spoon out of gallium, but if you use that spoon then to stir somebody's tea, it will actually melt, and the spoon will no longer be the case. We'll have sort of molten gallium in the tea. Equally, when you think about how weapons and other tools have been manufactured in the past, back in ancient times, such as making bronze swords, that would have involved melting metals so that they could be reshaped, put into a mold, and made into whatever tool or weapon that they were then going to be used for. So we can now look at these changes of state a little bit more carefully. So each change of state, so going from one state to another, each of those is given a different name. So if we start with a solid and we go to a liquid, if you want to think about in each of these cases what the names of these state changes are, and then I'll reveal them. And then of course we can go to a gas. So maybe pause the video here and maybe think what would be the name for that change of state of going from a solid to a liquid, from a liquid back to a solid, from a liquid to a gas, from a gas back to a liquid. You want to think about those changes of state. So if we go from a solid to a liquid, we go from a liquid to gas. So solid to liquid is melting. So when ice turns into water, ice is melting to become water. Freezing, equally, if you put water in your ice cube tray that you put in the freezer, it's called a freezer, sorry. So it is going to freeze that water to become ice. If we turn a liquid to a gas or a gas to a liquid, we could use the terms either evaporation or boiling. We're going to explain when it's appropriate to use which one. So evaporation is for a particular set of circumstances, boiling for a different set of circumstances, but they both describe a state change from liquid to gas. And then, of course, from a gas to liquid is condensing. It is actually possible to go all the way from a solid to a gas. There are some substances, not very many. So that's why I said earlier that most substances could exist as a solid, liquid or gas. There are a small number that can't exist in all three states. So, for example, you might have heard of dry ice. That's solid carbon dioxide. That goes straight from being a solid to a gas. There is no liquid state in between. When you make that change straight from a solid to a gas, that's called sublimation. Equally, you can reverse the process. You can go from gas to a solid. So an example here is iodine. If we took some solid iodine, we could turn it, and heated it, it would go straight into being iodine gas. Then if we let that gas cool down and it return to being solid iodine, that state change from gas to solid is deposition. Important to appreciate then that there are specific temperatures at which these state changes happen. They're called the melting point. They're called the boiling point. So these changes of state always occur at the same particular temperature. So if we're going from a solid to a liquid, that's the melting point. If we're going from a liquid to a solid, that's the freezing point. But they are actually the same temperature. Equally, if we were going from a liquid to a gas, it would be the boiling point. If we're going from a gas to a liquid, it would be the condensation point. So these are specific and particular temperatures. So if we look at a specific temperature, a specific substance, so if we look at water, the melting and freezing point of water is 0 degrees Celsius, and the boiling and condensing point of water is 100 degrees Celsius. So how do we know whether to use evaporation or boiling? So boiling is something that happens at a specific temperature. It happens at the boiling point. So boiling is only going to happen to water at 100 degrees Celsius. Evaporation is a state change which can happen below the boiling point. So if you think about washing your clothes and maybe you put them outside on a line or something, and you leave them there long enough, you'll find that they dry. So clearly the water that was in the clothes has evaporated, but it hasn't been a temperature of 100 degrees Celsius outside. Equally, if it'd been raining and there was some puddles in the road or puddles on the pavement or whatever, and you were away from them for a number of hours, and then you came back, you would notice likely that if the puddle would have disappeared, or at least at the very least diminished in size. So the water must have been changing state, it must have been evaporating. So both the terms describe the process in which a liquid changes state into a gas, but the boiling point boiling only happens at the boiling point, so we can only say that water is boiling when it's at 100 degrees Celsius. But evaporation can happen at any temperature below that boiling point. So water can evaporate below 100 degrees Celsius. The only real difference, I guess, is the time it takes for this to happen. It's much quicker when a substance is boiling. The state change is much quicker. Then finally, one of the things to consider is that when we're talking about state changes, or changes of state, what we're really talking about in terms of science terms is a physical change. Something that you'll do later in the year is the idea of a chemical change. So here we're just focusing on a physical change. Changes of state are an example of this, and as a useful rule of thumb to try and decide whether something is a physical change or not is that they can be reversed. So physical changes can be reversed. So if you can melt ice to become water, but of course you can freeze the same water to go back to being ice. So you can reverse the process or reverse the change that you've made. So if we think about how we could define it, we can think of a physical change as a way in which a substance changes how it looks or feels, but you're not actually making anything new. So clearly ice and water look and feel different, but they're still made up of the same substance, water. It's still water that makes up ice, and obviously water that makes up water. You can reverse the process. So the most common type of physical change is the one we've been considering up to now, which is when you change state, so a solid to a liquid or a liquid to a gas or vice versa. But the other type of change that I just want us to recognize at this point, even though we're not going to say too much about it beyond now, is anything which we can count as being a mixture. So if you mix something, and then of course it says if it can be reversed, so what that means is if you could unmix it, not always the easiest thing to do, but if it's possible and relatively straightforward, then that is another example of a physical change. So for example, dissolving salt in water, mixing that salt with water. If you then evaporated the water or boiled the water off, you would have the salt left behind, so you would be unmixing it, so to speak. So that's a reversible process. Examples of physical changes, so you'll see here they are either, the examples that I'm giving here are either state changes like the ice cube melting, or they're mixtures such as dissolving salt in water or stirring sugar into a cup of tea. It is possible to unseparate the salt and the water and the sugar, well, from the tea. Not easy actually with that last one, because there's actually a number of substances in there, but still possible. And then non-examples, well, we've got here burning a match, making bread from a dough, making alcohol, cooking an egg, nail going rusty. These are all examples of something you'll do later in the year called chemical changes. But one thing I hope you could recognize at this point is that it would be extremely difficult to reverse any of those, to unburn a match, to return your bread to dough, to return your cooked egg to the runny egg that it was at the beginning. Most cases impossible. So that concludes the first video about the topic of solids, liquids, gases and particles. And if you have got any questions, just let me know.